In other videos, we've discussed the importance of the member local access system as well as methods to modify the default orientation of the member local access system. But the purpose of this video is to explain how the default orientation of the member local access system is derived. So to understand this set of rules, we'll focus on member B2 here, and I have the members table open so that we can refer to that. Now, there are three simple rules that are used. The first one is that the member local x-axis always goes from the starting end of the member to the ending end of the member. So x color is red, so we're looking at this red line here. And for member B2 in the table, we can see that it spans from node number 3 to node number 2. So if we envision a vector that goes from node 3 to node 2, then we can understand why the red axis points to the left in this rendering. The second rule says that the member local z is found by the vector cross product of the local x-axis that we just found crossed with the global y-axis. And the easiest way to picture this is to use your right hand, point your right fingers in the direction of the red axis, and envision curling your fingers up to swivel that red axis into the vertical or the global y-axis. When you position your hand in that way, your right thumb will automatically indicate the direction of that vector cross product. In other words, what that's telling us is that local z will be pointing into the screen or into the plane of the frame away from us in this view. And that's what we see when we look at this blue axis. Now, the only place where we need a caveat to that rule is for members that are vertical. So if we were to take a look at the columns, for instance, we can't take a vector cross product of two parallel vectors. So instead, we just have a convention that we adopt that says the member local z-axis will automatically be parallel to the global z-axis. And we can see in both columns that that's true. This column as well as this column have their blue, or remember, local z-axes pointing out of the plane of the frame toward us, and in fact in the same direction as the global z direction. So that's evidence that that convention is being used. The last thing that we need to remember is just a simple math rule that says that the local y-axis can be found by local z cross local x. So again, if we take our right hand and we envision using our right fingers to curl this local z blue axis into the local x red axis, that means that our right thumb will point upward, and the green local y-axis shown here on this member confirms that our right thumb is heading in the right direction, that the model is doing the same thing. It's pointing the local y-axis upward.